let us proceed to the second session with our second speaker, which entitled VR Technology in Construction Using Data from Reality Capture. Without further ado, I would like to invite Mr. Bruce Kong to the floor to deliver the talk.
Hello, Mr. Bruce.
Hello, can you hear me loud and clear?
Yes, clear, Mr. Bruce.
All right, loud and clear, that's good. First of all, thank you again, members, all the moderators here, the host, our lovely MC as well. Thank you very much for having me. I must say this is one of the new norms that we're getting used to as well, conducting a virtual seminar as well.
It seems like they have some disturbance, some noise, something like that. It's a new norm.
Yeah, we're getting used to it. So if we can progress, like Gary said, from dial-up to instant Wi-Fi, I think we can get through this and have a
Mr. Bruce.
Okay. I want to just maybe see, all right, is everyone awake? Can I get everyone to just wish each other good afternoon in the chat, just to see who's awake? We have quite a lot of people. Yes, thank you. Yeah, we have quite a lot of people in the session today. Yeah, so wish each other good afternoon. Good night. Not yet. Still early. Yes, good afternoon, everybody. Okay, so my session today, as was introduced, is actually about VR technology in construction using data from reality capture. Okay, so I'm going to try and move as fast as possible to cover this interesting idea about using virtual reality. Okay, and so what I'm going to go through today with all of you in this session is basically, I'm just going to quickly introduce about myself and the company that I represent, so at least you understand who we are and where we're coming from. I think maybe there has been a bit of an introduction from some of the previous speakers that came on today as well, like earlier this morning with Mr. Michael from Bina Schedules and also Ms. Punita from Bina Initiatives. Okay, yeah. So run through a couple of topics, introduce about Bina. Let's talk about what is reality capture and our understanding of it. Then we look into the features and constraints and when it's useful. So with any technology, we gotta sort of like manage our expectations, right? What are the advantages and disadvantages, things like that. Then we're going to try and look at understanding the types of data generated from this concept called photogrammetry. And then finally give you some use case scenarios to sort of like expand your mind and look at, different possibilities there, maybe even outside of construction, right? Consider your future options, and then let's go into Q&A. Okay, so quite a lot to go through. Hopefully, I can finish all this on time. Okay, so a quick story about Bina Initiative. So if you see, we're basically end-to-end solutions provider. I think some of my previous colleagues have mentioned this before. We've been around since 2009, doing from concept and design to construction, handover, and facilities management. I've been fortunate enough to be working here, I think close to 5 years already, yeah. And throughout that time, we've been able to work with many different global brands around the world for all the different end-to-end solutions that we have. So quite proud to have that achievement working for this company. And also with partners such as Novate, which is Mr. Gary earlier, the presenter, Trimble, Matterport, Power Project, Oracle, which is what Punita presented on earlier as well. So all this. These are not just the only brands that we have. We actually cover quite a wide range, of international brands doing all the different end-to-end solutions there: design modeling, budgeting, costing, planning, scheduling, construction, quality and safety management, even facility management. So looking at all those brands and all those solutions and things like that, when we go and look at customers, our focus has always been on providing like a holistic approach. We look at the people, process, and technology, right? So obviously in this particular situation here, UTHM, you are our future people, and hopefully you will be the future to develop the technology and also to teach us the new process as well. Okay, so everyone listening, our future is in your hands. Okay, all right. So with this approach there, we've always looked at the end-to-end solutions from concept, design, construction, completion, and until operational phase, right? So if you look at this throughout any construction project, we focus on digitizing the different processes involved at all these different phases. Okay, all right. So having said that, let's go back to the topic today, which is VR technology in construction, virtual reality, and using how we can use data from this reality capture, this concept of reality capture. So quick question again, I want to ask you all, if once you say VR, say yes or no, was this the first thing that you guys thought about? Is this what you guys thought about when you all saw the topic?
Yes.
Your goggles in and then having a experience of the construction site, or maybe even building a building or infrastructure and everything. Yes. PS4 VR. Yes, virtual reality. Correct. Yep. Okay, so you're not far there, but but what I wanted to say is that if you look at this, all these different examples that they're put in there, right? What they're looking at is just they're basically putting a screen in front of their eyes and to visualize and interpret a reality which is outside of their room or space, right? So obviously they're looking at the screen, but they're not looking where they are. They're looking at something else, a visual representation, right? Okay, so it's a different reality. So now, understanding that, let's look at what is reality capture, or rather, what is the practice of capturing reality in this sense? Okay, all right. Wait, in the chat there, someone needs to translate that for me because I don't understand, man. I can't read Chinese.
晚上好，晚上好.
Oh, good afternoon. Yes, everyone.
No, actually he said good night. 晚上, right? Dr. Ashraf. I think he's just trying.
Okay, all right. So, let's look at what is reality capture, or the practice of capturing reality. Okay, I want to sort of like get this concept introduced to everybody here before we move on to some of the examples and case studies here. Okay, so in a sense, when we look at the reality that surrounds us, our surroundings, new environments and things like that, what do we try to capture? I mean, from a technology point of view, maybe from a constructor's point of view, right? We want to observe and we want to capture what we observe. Okay, so how do we do that? We have a drawing, we have a painting, we do sketches, we even take a photo, right? If we go back in the days of the early explorers and things like that, when they're traveling around and they encounter a new world with new animals or flora, fauna, and things like that, what do? They want to capture what they observe, right? So then they'll use drawings, sketches, things like that, right? No Instagram photos last time, so they actually had to draw detailed diagrams, okay, of what they observe, all the different flora and fauna and things like that. And then after capturing what they just generally observed, right, we also want to start measuring as well. Okay, we understand what we see, but then now maybe we have a further question about the length, weight, volume, time, temperature. We want to quantify what we just saw. Okay, yeah. So then we want to measure, not only to observe, we want to measure as well. And then and I think as technology progress, as humans develop, things like that, right? We also start to want verification as well, right? Because maybe in the observation and the measurement process, early on, there is some sort of inaccuracies, things like that. And it's all very anecdotal as well. So we started developing like maybe specialized equipment, IoT devices, even incorporating the two new things such as machine learning and artificial intelligence. Something that our previous presenter, Mr. Gary from Novate, touched on as well, right? We want to verify exactly what we observed and measured as well, okay? So now, looking at this thing of observing, measuring, and verifying, okay? What is reality capture that we want to do, which is we want to observe, we want to measure, and we want to verify. Now, that's the general overview of it. Now, if we dive into a specific technology, which is what I want to talk to you about today, there's this term called photogrammetry, okay? So photogrammetry is a process of scanning and capturing any site. Okay, so it could be a even existing plant, could be building, or even a crime scene as well. Okay, and when you use this technology, it basically combines measurements and imagery together at the same time. Okay, and then from there you can export this data out, and then you can actually create a 3D environment on screen. So whether it's a computer screen, or in the previous example I showed all those guys with the goggles on their face, right? So photogrammetry. Now, quick question: what do you guys think would be sort of like the applications in construction, or maybe even just about reality capture as well? If we look at our need to observe and measure and verify, right? What are some of the common practices that would be in a construction site? What do you guys think? Anybody? If we are to look at, what would you need to do to observe or measure or verify at a construction site? I'll give you a little hint right now. Two main things, two key areas would be survey, and then another one would be in the actual construction process itself. Okay, so if we look at during the survey, what would you need to observe, measure, or even verify? You will want to look at your project site. Have a quick overview of your project site. You want to understand your boundaries as well, because it's illegal for you to construct over what is your boundary. What is your land, allocated land space, things like that. What are your existing site conditions, right? Within your site itself, it could be soil, it could be ground, things like that. And what are your surrounding constraints as well? Okay, so maybe as an architect, you want to understand sort of like what are the surrounding buildings, and maybe you want to do a solar or a shadow study, for that, right? Maybe as an engineer or main contractor, you want to understand your supply, delivery constraints, things like that, right? If we're looking at construction itself, during the construction process, we want to look at the design and build comparison. What was designed is what was built, right? Supply and delivery tracking as well. We can actually use that where we can actually observe using photogrammetry and also methods of reality capture. We want to observe materials being sent to the project site, right? And then also maybe risk assessment as well. Gary touched on just now about a bit of safety inspections, health and safety during COVID-19 and things like that. Even documenting changes, what's been happening on site, right? So these are just like some high-level applications of photogrammetry, and also about reality capture in general. Okay, let's expand this a little bit further. How else can we use reality capture in a construction project? Okay, two more that was touched on earlier as well. Okay, one of it is actually for quality and safety. Another one is planning and scheduling, right? So when we are at a construction site, what do we want to observe? What is the purpose of the observation? What do we want to observe, measure, and verify, right? First one is quality and safety. We want to look at accurate defect management. Okay, we want to look at real-time safety monitoring as well. Okay, and for planning and scheduling, we want to look at progress reports, and we want to look at real-time updates. Now, these are just high-level ideas which I want to just put out there for you guys to consider. I'll come back to it in the Q&A if you have any questions about it. But for now, I'll just quickly move on, okay, with my presentation first. Okay, so now, first thing to understand about photogrammetry and how you are actually basically creating this virtual reality for yourself, right, is you must understand the types of data that is generated. Okay, this is important. So first thing is that the type of data that is being generated first and foremost is what is called a point cloud. Okay, second one is a photo image. Then third one is, depending on the system that you use, you might get coordinates as well. Okay, and this is sort of like the basic understanding of photogrammetry. Okay, depending on what technique you use and what machine you use, this is the basic data that will be generated. But then obviously, depending on the machine or whatever, it might come in different formats. But this is the basic data that you will get. Okay, now I'm gonna then play you a video just to have a better understanding, better explanation.
To capture a digital representation of a space, a laser within the scanner case rotates at high speed.
Yes.
As the invisible laser beam hits various objects or materials, their position relative to the scanner and to other elements of your site or building is recorded as a piece of digital data. This is known as a point. When several of these points are collected, they begin to build a highly accurate three-dimensional digital picture of the space or site being scanned. A large collection of these points is commonly referred to as a point cloud. Now, it might sound obvious, but the more points you collect, the greater the accuracy of your scan. This is commonly referred to as a scan's resolution. There will be times when you need the highest possible scan resolution, but this isn't always necessary, and it comes back to determining what you want to use the scan data for right from the outset. The scanner automatically rotates during the scan process to capture the area being scanned. It may perform a complete 360-degree rotation or a lesser turn depending on the data to be captured. The Trimble TX8 can capture points up to 340 meters away with its extended range. The scan area and your desired resolution are all entered as part of that parameter data we mentioned earlier on. To give you some idea of the magnitude of data collected during a typical 3D laser scan, the Trimble TX8 collects data on 1 million unique points every second. That's around 300 million points during a 5-minute scan. 3D laser scanning removes a large degree of human error from the surveying process and enables significantly higher volumes of data to be collected over a considerably shorter period of time. This means that survey information can be relayed to project teams faster. It also enables surveyors to undertake more scans than they could have done previously.
Okay, so that basic explanation there is about laser scanning. Okay, so you have that machine, you put it at one spot there of what you would call a control point, okay, which is a specific coordinate on your construction site that you want to do the scanning and then run. So like I said, do the 360, send out all these laser points and then generate that point cloud data for you, right? So that is sort of like one of the standard or standard methods in construction that's being used for reality capture, right? Now, one other method, this new method that this new technology that's developed, called photogrammetry, is slightly different. Okay, so let me have the actual expert itself explain this in better detail.
A picture may be worth 1,000 words, but if you were trained in the science of photogrammetry, it's also worth 1,000 numbers. Photogrammetry is the science of applying geometry and mathematics to make measurements from photographs to extract 3D information. Artists as far back as the Renaissance understood the concept of perspective and geometry in flat imagery. Leonardo da Vinci famously painted scenes that were as real as looking out a window. And 15th century mathematicians developed formulas for how objects should appear in space. When photography was invented, the same mathematic principles that had been used to simulate the real world on canvas were used to make measurements of the real world from a recorded image. Scientists developed techniques for measuring objects and determining distances and coined the term photogrammetry. Combining photogrammetry with the technology of flight enabled photogrammetrists to make more accurate maps and terrain models, and satellite photos were used to scout the moon for the first Apollo landing. So, to a photogrammetrist, a picture may be worth 1,000 measurements, and if you have multiple images of something, those 1,000 measurements aren't just multiplied, they grow exponentially. By using multiple overlapping images, photogrammetrists can see scenes and objects stereoscopically, or in 3D. By measuring in 3D, photogrammetrists can create highly detailed models of anything in a picture.
Okay, all right. So if anyone used to question whether or not the math and geometry was important or not, see, this is one of the good applications of it. Okay, so now with that explanation of laser scanning and photogrammetry, okay, one more thing to sort of like understand from that is basically we have to look at the features of that technology. All right, now, when you talk about laser scanning and also using photogrammetry, there is basically a speed versus accuracy issue there. All right. So what is fast may not be accurate, and what is accurate may take a lot more time to do. Okay. So that's one thing to consider first. Next thing is actually the constraints, because Now, different levels of accuracy will, you will get different levels of accuracy in terms of your measurements or your reality capture, right? Depending on the equipment that you use and also your scanning methodology as well, right? So like for instance, in the earlier example of the laser scan, when he takes that control point and puts it in the room, he can choose to either put it in the center of the room and just do a full scan of the entire room one time, or he can put it at 4 or 5 different points of the room to actually develop more points and higher accuracy, right? So that's talking about scanning methodology. If we are looking at the example of maybe flying a drone, okay, over a site as well. So that drone, as it flies there, you can also indicate how many pictures a second it will take in its flight path, right? And even the speed of its flight as well. Okay, so there's different levels of accuracy as well according to your scanning methodology. All right. Then, so question would be, when would this be useful? Looking at photogrammetry or laser scanning, when would you want to use this technology and when would it be useful? So don't hate me for this answer, but depends on what you're going to use it for. Okay, so now let's fast forward a little bit to some case studies, and then let's come back to talking about like exactly what what are some of the specific use case scenarios that we can look into. Okay, so I'm going to go with the first example here. The first example here is taken from Siemens. All right, the Goodwood Hill climb is sort of like it is actually a motoring event. Happens every year at West Sussex in England. Okay, so the Goodwood Hill climb is this track where people race on during what is called the Goodwood Festival of Speed. So it's just a big event where all these car enthusiasts can come and experience and enjoy themselves, right? And in this situation here, the Goodwood Hill climb, this particular track there, they wanted to capture the site conditions there and then let people at the Goodwood Festival of Speed experience the track for themselves. Okay, so in this situation here, we look at 3 different things: the data capture process, the processing itself, and also what would they try to experience with that. So in the data capture there, right, what they surveyed was a 1.16-mile track. Okay, that was the Goodwood Hill climb, and they used a combination of drones and also a vehicle for the laser scanning, right? And then how did they process this? They basically used software to automatically combine everything into a reality mesh, okay, and then created that site model. And then finally, obviously, that's how they were able to generate this 3D model for people to experience, all right? Let me just quickly play this for you guys and then I can explain further.
Through the partnership between Bentley Systems and Siemens, we are making digitalization real. We look at different technologies that can help us bring the physical world into the virtual environment. But down here it's quite open and we should get good data. So today's quite challenging. At best we have 2.5 hours to capture a 1.2-mile hill climb at Goodwood and turn it into a really rich and compelling 3D model. Now we're capturing the actual physical environment down to centimeter or even millimeter precision and accuracy. And that's really unique. It's digitizing the physical environment in a way that's just been impossible before. I've always wanted to come to Goodwood. So what a great opportunity today to come out here and do what we do best. It's a really exciting time to be involved in this technology. We can now capture industrial assets. We can capture automotive plants or gas plant to enable us to drive greater efficiency. We can do that every day. We can do that every day on a construction site to see how construction is progressing, we can check for health and safety issues. So the potential for this technology is just boundless. For example, driverless car systems. Those vehicles need data. Our technology is already starting to be used for those applications, for mapping entire cities in detail and being fed into autonomous vehicles. So I can see that there are new ways of applying this technology that we haven't even thought of yet. Bringing the physical world into the virtual enables Siemens to make the physical world better.
As you can see in that particular example there, the application of reality capture, the main objective there was actually speed. as what was mentioned, they only had about 2.5 hours to capture that 1.16 mile track. Okay, so for them, they were willing to give up a bit of accuracy for the sake of speed, and they used a combination of drones and also their vehicle with the laser scanning, laser scan as well. Okay, so here you can see that using this quick combination, they were able to very easily generate like a simple 3D model of the Goodwood hill climb. All right, so in this particular application, speed was of the essence. All right. Now let's just go and look at another example. This one is by ATFF. They are actually a company based in France, specializing on 3D reality capture. All right, so they have various solutions, and for them, it's more about accuracy. Okay, there's two examples that that will be shown over here. So over here, like I mentioned, ATFF, their method of data capture is they use combinations, laser scanners indoors, drones mounted with cameras, even mobile mapping using a scanner attached to a car or even a backpack as well to fill in the gap. So they use various different technologies to really paint the entire site so that they can have a full 3D capture of the site conditions. All right. Now then, from there as well with the processing. Now, this one here is actually a quote from one of their, from someone from ATFF, which is very interesting. How they view is that reality capture is the inverse. For them, we collect all the data and after we filter what you need. So for them, when they go to a project site, they look at accuracy, which means that I'm going to implement all the tools available to try and capture as much reality as possible from the site, and then only look at filtering out what I need and don't need after that. Okay. Now, two examples I'm going to show you here of what this can be used. One is actually this hospital up in the Alps. Okay, and then another one is sort of like using 3D scan for event logistics simulation. All right.
ATFF specializes in reality capture. For this project, we use laser scanning to capture the inside of the building and as well the drone to capture the outside of the building. The very good benefit of ReCap is to be able to assemble some laser scanning and photogrammetry, and like that we can recombine all the information from one side. As soon as we create the point cloud, the architect can get the data we are generating in ReCap, and he can import those one into Revit or use it in Navisworks. Using ReCap, it's pretty easy to visualize a project. This helps as well to have a better vision and take some very good decisions and to see things quicker before the work is starting on the site.
Okay, so in this example here for the hotel, the important thing was that they were going to be constructing this hotel, this hospital, right? And they needed to have accurate site data, not only just for the contractors that were actually constructing the building on site, but they actually had to feed back the measurements and verify the measurements to the architects back in their HQ as well. Okay, so in this particular situation here, the data flow was in two directions. One was down to the contractors so that they can have accurate information about site conditions. And then also it was back to the architects as well so that they could compare that to their drawings to see what was built and plan for any adjustments required. Okay, now let's go to another example here. This is another one quite interesting by them. So here ATFF did different thing, which was they tried to simulate the logistics of an event. Okay, now this data over here was taken from a combination of existing GIS data, right, from satellite images, and also their own drone flights as well. So it's a combination, and as you can see, there are some trucks in the background there, and there's also some stands here as well. So they've actually used the point cloud data, the reality data, and simulated for their 4D, which is the project delivery and setup. So here they can actually look at how trucks would come in, bringing in the setup for their stage, for the lighting equipment, and things like that. And they can potentially simulate the constraints that they might face. You know, I think if I'm not mistaken, this part of France is an old part of town. So there are actually a lot of old buildings, historical buildings that they need to take care of. And obviously with all those trees, they can't just cut things down. They need to move through that and manage as well. Here you can see that they are now going towards an overview where after they construct the stage, in their planning of construction stage, they have to look at very tight tolerances as well, you know, where they will position all the different elements, you know, so they want to use the point cloud data for their logistics planning, okay? And then hopefully make sure that they can sort of like have a digital construction before the actual event itself, okay? All right, so this is another use case scenario of reality capture. All right, now the last example that I want to go through, okay, so we looked at speed versus accuracy in terms of the different use case scenarios for reality capture, okay, and how you would actually implement it. Now, another example here is actually from Matterport, where they actually use it to create an immersive 3D digital twin, right? And so this can be used for back to the examples given here, back to work planning, project listings, or for real estate agents to promote their properties, even for documenting renovations, you know, and existing construction projects, right? So now in this solution here, the reason why I bring this up is because now in the previous two examples, you can see that Topcon used a very expensive Falcon drone, and also they actually had to mount their own proprietary laser scanning tool onto a car, right? In the ATFF case, they actually went and used a combination of different drones and ground scanning equipment as well. Matterport, I just want to bring this up because when we start to look at reality capture, there are cheaper tools that are being made more and more affordable as well. Like the example that Gary mentioned just now, we got dial-up back in the day to automatic Wi-Fi now. So as technology has progressed and become more and more affordable, the ability to capture your own reality has become more and more widely available across different tools. Okay, and this one example they want to show you is actually using Matterport. So let me just give you one example here that I'm going to run through. So two examples over here. First one is sort of like using reality capture as a factory tour. Okay, another one is actually using it as a detailed walkthrough of a mechanical room operation. Okay, I'll show you what I mean. Let me just share my screen here. All right, let's look at the virtual tour, the factory tour. Can you all see the screen over here? No problem. Let me see whether my screen sharing has changed or not. Yes.
Yes.
Yeah. So we have this is a quick scan of what is a turbine hall, okay, Chapel Cross turbine hall. And the points that you can see on the ground here is where they've placed the tripod, and they've actually moved the camera around and taken a 3D scan of this Chapel Cross turbine hall. And that allows you to share this across the internet to anybody, whether it's through WhatsApp, email, or whatever, or maybe on a Facebook page or website. And they can then have a tour of the facility themselves. So you could say this is something useful as maybe just a marketing tool. Let's say there are investors coming into your company and you want them to have a quick tour of your facility, you know, or it could be a quick introductory tour to new workers, you know, that want to have a better understanding of their new work environment and, you know, things like that, right? And this is using inexpensive equipment, well, much less inexpensive compared to sort of like the Falcon drone or the Topcon laser scans in the previous examples given. All right. There's a bit more of a walkthrough here, but if you want, I can share the link to this in the comments later. Then you all can click on it and have fun with it yourself. Okay. All right. So here is where they've basically captured they created a virtual tour of the Chapel Cross Turbine Hall and then made it available to anybody that wants to visit it in the future. All right, so this is one example. Now, how do we build on this capability and make it even more useful? So the second example over here is, again, the same thing. As you can see, they're still the same spots on the ground. They've taken the tripod with the camera. They've gone around and then they've done a quick 360 3D capture of the entire environment. Now here is where it's more towards using it for training purposes, and also for tagging specific machinery for maintenance, for repairs, things like that. So they've combined the solution, and as you can see, we've got all these tags here. Let me mouse over it. So this one particular tag here, as you can see, once you mouse over it, a pop-up comes out, and this actually links to operation documents. All right. And so anybody, let's say it's a new person in charge of maintenance, or it could be a third-party company that's responsible for servicing or repair, they can easily access this virtual tour to have a look at what are the operation documents over here. Let's say maybe they might not have an understanding of what are the shutdown requirements for this facility. They can again look at the particular item and then access more information over there, right? If we go to the back of the room over here, you can see that all the switches are all easily labeled as well. Okay, so instead of going into maybe like trying to search for documents, paper documents, and things like that, you can just easily pull up your mobile phone, call out the virtual tour, and actually have a quick reference to see, to pull the information that you require over there, right? At the same time, you could even include the fact that they could even include their own tags into it, and then indicate whether or not something needs to be repaired, or needs to be replaced. Okay. All right. How am I on time at the moment?
Yes.
No? Okay. No problem.
No problem.
Okay.
We have another 30 minutes.
Okay. So I think now before I go into the next part of it, let me just quickly look at some of the questions over here, because we are talking about the different case studies here, and the purpose of me sharing that is to try and sort of like pique your interest into thinking about what are the different applications there, right? So yeah, some people suggested, yes, you can actually scan FTK campus and give a virtual tour to everybody else, introduce your lovely campus to other students that are thinking of enrolling. Yes. Is photogrammetry being used for Google Map scanning too, or are there some differences? Google, yes. So if you all notice the car, there's actually a car with their camera array on top that drives around. It's using the same technology there as well. So as the car drives around, it's constantly taking pictures of its surroundings, compiling all of it, and using that photogrammetry way of calculating is then generating that 3D map, that street view that everyone is familiar with, right? And then if you go into the, when you're viewing it on desktop, when you click on the topography, you can even see a bit of elevation and things like that, right? Not very accurate, but just enough to see what are some of the high and low areas and things like that. Yeah, that's all from your photogrammetry. Okay, all right. Let's see, there's another question here for first years that just learning drafting, if you have a proper course into pengguna technology need. Well, now, so that one, if we go back, that's a very good question. Now, if we go back to the speed versus accuracy thing, right? So if you talk about cost there, you have to look at things like this. What are you willing to pay for to get both, right? So depending on, let's say, the limitations to your budget, you might get something that's very fast, but accuracy very low, right? And in the reverse there as well, you might get something that accuracy is very high, but the actual speed of getting the accuracy is very low. But then if budget is not a constraint and you have the money to spend, then you will get closer and closer to having both features or both benefits at the same time. Like for instance, like the TopCon the example by Trimble where they actually had a laser scanner. I didn't include in the later part of the video, but there's actually a camera located in front of that laser scanner. So while it's doing the 3D scan of it, it's also taking high resolution pictures as well. And using their software technology to calculate, is developing a skin to actually overlay onto the point cloud to generate your virtual reality there. All right. Now, if you want to look into the cheaper cost, yes, I'm going to go into a few examples, options for you guys, where we talk about what is the future options and what you can explore. Okay. All right. That should be quite interesting for some of you. Let's go back to the slides. Yes, Lufti, yep, Street View. Yeah, that is the same concept of photogrammetry. Okay. Okay. So now we looked at some examples there from the Goodwood Hill climb, from the company in France called ATFF, and also from Matterport as well on applications of reality capture. So let's have a quick understanding of what is the data capture process actually. So quite
sorry,
simply,
Mr. Bruce, can you please make the slide full screen?
Oops, I think yeah, swap. Let me do that. Okay, I think it should switch already by now.
Okay.
See the main screen now? There's a bit of lag at the moment. Yeah.
One question, Mr. Bruce.
Yes.
Okay. How does the VR technology capture the data in the water? For example, for dredging work, to know the depth of the seabed. How does the VR technology can be used?
Okay. So if we are to just, let me see whether I can find the slide for all of you. Hold on. Yeah, okay, wait a minute. Let me just see. Are you seeing the main screen at the moment?
Yes, full screen now. Thank you.
Full screen? Yep.
Yeah.
Okay.
Thank you.
Right. Then I think the Facebook one updated already. Okay, so again, if you go back to the reality capture and the data there, right? So we're talking about data that's being generated. So there's point cloud, there's photo images, and there's coordinates. And if we look at the example of above ground, yeah, like what we said just now with TopCon, with Goodwood, they used the laser scanner on the car, they had the drone flying, things like that. Underwater now, it's just a matter of how would you generate point clouds underwater. You can't use laser, it will be, there'll be refraction, and things like that, right? So you would have to use sonar or radar. All right, so that would be the option there. There are some technology where they combine a different kind of laser, but I'm not too familiar with the technology that, which can generate a point cloud using that method as well. Yeah, so that means you are firing a different kind of laser to map out the area. Yeah, but yes, so same thing. You would just have to send a different kind of vehicle into the water, basically paint the area with, and then generate your point cloud and your images and your coordinates to have your data. All right. Okay, good question. Yeah. Let's just have a quick one here. Use of drone need to apply with Civil Aviation Authority 14 days early, need to pay around $250. Does it affect the progress and increase costs, especially for the survey and construction works? So I think this one is something that is interesting because I remember a while back, there were talks about any drones had to be registered with the Malaysian Aviation Authority. Then after that, they said you have to pay a fee and all that kind of stuff. I'm not too sure what is the latest development now. All I understand is that the application of the fee, or for that you have to pay, right, is based on, I think, the the number of propellers on the drone or on the total weight of the drone itself. That's what I remember from our last conversation with the planning authorities and things like that. And so, will this affect the cost? Yes, if you need to go and use higher end machinery. But then, in the example there of, let's say, when we talk about speed versus accuracy, right? Actually, your standard DJI drone is actually able to be used to generate a point cloud data for a construction site with acceptable level of accuracy for surveying actually, right? So yes, there is a cost issue there if you need to go to a higher level of accuracy, but technology now is getting better and better and better, that even your sort of like consumer level drones are able to be used. All right, good question. Yeah. So now, having said that, with the let's go back to what was the reality capture process. And what we want to talk about there is that so we went through all these different examples there and things like that, right? Now, just to give you a quick overview of what is involved in actually getting there with the examples that were shown. So obviously on the first end, you need to have some form of capturing the data, the point cloud, the data there, right? The point cloud, the images, and also the coordinates. So here you have your typical camera, you got your fancy laser scanner, you have your drone, and in certain situations as well, your underwater vehicle, right? And then after that, you need to have a level of a stage of processing, because all this raw data, right? I'll give you an example back in the laser scanning as well. Laser scanning, it will be based on control points. That means you look at a construction site, you would then put down 4, 5, 6 points on the map, and you would plot this as that's exactly where your laser scan will be planted to do its 3D scan. So let's say if we have a triangle, a rectangle, and you go and put 4 points on each corner, all right. Each of these scans would then generate one particular point cloud, like a jigsaw puzzle piece. Right. So now you have 4 jigsaw puzzle pieces. How do you put it together? You use the control points to determine the specific angle and rotation of your point cloud and stitch it back together. So that's where your processing happens. Okay. Then from there, after your processing, you need to do a bit of editing as well, because we have had instances where we were asked to process 3D data, right? And the client gave us a huge file, of a lot of 3D, virtual VR data, 3D data, reality capture and things like that, right? But we still needed to edit a lot of it, and then before it could be usable, And then finally, you arrive at your reality content, and once you have your 3D model available, right? What is your virtual reality ready? That is where you can start to consume it, where you can look into maybe going to your design, you can actually visualize and animate it, you can even extract features for your own consumption as well. That means, for instance, you want to scan like a particular building as an example, then you can take that building and export it out into another construction site model, all right, for your own planning and verification as well. All right. Now, one thing to understand here is that when you talk about photogrammetry, right, there are many different options there also for you. So if you go back to the cost that was asked by Mr. Lufti, right? Okay, so you have many different options here. Okay, I think it feels like I just designed this slide specifically to answer that question. So yeah, because I think I knew some people would be asking this, right? So you do have. So let's say we look at a construction site on the right-hand side, a brownfield, or maybe a brand new site, right? A greenfield on the left. Okay, so on the ground itself, you have from left to right, expensive specific options, all the way to, if you notice on the right-hand side there, an iPhone. Okay, Mr. Gary mentioned also, I think he did a survey, but nobody dared to answer who owns iPhone 12 at the moment, right? Well, I don't have a iPhone 12, so even I think my Samsung is still a S8. Yeah. Anyway, so you do have quite entry-level options there. The example shown there is the iPhone 12, but some technologies you can even use a standard, I think up to iPhone 6 or your Android, as long as it's operating on Android, I want to say Android version 7, which is, I can't remember which dessert that is, but yeah, like that. So you have a few entry-level options if you're scanning from the ground, okay? Right. Then after, if you go, if you go up into the sky, then you have even more options. So you have your DJI, right, which is your consumer level. You've got your quadcopters, you know, which are a bit more expensive, and then you've got your UAVs as well, right? All this depends on the amount of space you need to cover. So again, back to that speed versus accuracy, right? Another option actually is, you may or may not believe it, but some of your terrestrial scanning services as well. There are certain websites which you can actually use to download topography, you know, visual maps, you know, and things like that, right? And it is quite affordable, you know. And obviously, the cheapest one that you can use, Google Maps. Okay, all right, yeah. So so when you want to look at incorporate starting to use reality capture as an engineer, as an architect, as a main contractor, you know, maybe as a site engineer and things like that, right? You have to look at what is the use case scenario, and then your deciding factors are speed versus accuracy, right? And then from there, that will inform you on what is the different kinds of applications or software or hardware that you need. Okay, all right. Now, again, this is just back to the earlier slide there just now. Yeah, so incorporate, once you apply all that, what you can generate is basically point clouds, photo images, and also coordinates as well. Okay. Now, I hope I have a bit more time. I'm just wondering, yeah, am I okay on time at the moment?
Yeah, sure, Mr. Bruce.
Okay. All right, great. Yeah, so one more thing specific to FTK for students like you guys going out into the construction world, okay, is actually this concept which is getting more and more prevalent. I think you'll probably hear this term, scan to BIM. Okay, now scan to BIM is sort of like, yes, you have what is called the BIM process, and I think my general manager, Mr. Kumaran, and some of my colleagues from the earlier slots explained about what is the BIM process, you know, incorporating 4D, 5D, and things like that, right? So scan to BIM is where you're trying to take reality capture, all right, a virtual representation of the surrounding environment and putting it into the BIM process. Okay, and this is a two-way traffic. All right. Now, for those who may or may not know, one important thing to consider here is something called level of detail. Okay, so on the left-hand side here, if we go through the different levels of detail in a BIM process, right? At the early stage, you only have LOD level of detail or level of development, which is at 100. So it's very basic. We're just planning. We just want to look at the space, you know, the very basic measurements at the moment, right? And then as the construction, so it's the basic graphical representation of the building or whatever you're trying to construct at that time, right? Then as the LOD increases, you start to get more and more developed, you know, so here we're still using generic, we're not getting specific yet. And then finally, as the level of development or level of detail increases, as the project starts to move through the different stages from concept and design to actual planning, costing, and finally to construction, that's where your level of detail increases. Okay, now the critical part here is LOD 500. So at the point of LOD 400, you are basically over here. All right, I hope you can see my mouse here. You're basically over here where as a designer or engineer, you've included the full range of information, construction information into your drawing or model. Okay, right. So that's LOD 400 or 450. That's depending on people's definitions. Now, LOD 500 is where you actually have to do a field verification. Okay, where what is designed, what is constructed must match what is designed, or rather, it's called as-built verification. things like that, right? And normally this is done with a combination of people just going on site and doing actual verification. That could be the clerk of works, or it could be the QS, the representatives from the engineers, the main contractors, and even from the project owner itself, right? So scan to BIM is one practice now where we're actually using all the different technologies that I shared to actually then do a reality capture to do and use that as the verification process. That means you don't have to go physically on site. So imagine the example by ATFF, you actually deploy your resources and capture everything on site and then share it back to the HQ for them to do as-built verification based on real data. Okay, right. Now hold that thought for a moment, because it can go the other way as well. So in this example over here, right, the scan to BIM process is where we are trying to look at going into existing facility here. All right, so we go to an existing facility, we do a scan of the area and generate a virtual tour of the place, right? Okay, and then after that, so this is scanning and processing. After that, you can actually use that to generate your point cloud. Okay, and then from your point cloud, you then use that based off those measurements, you have your 3D model already. Okay, right. So, and then after that, once you have your 3D model, whether, depending on the tools you're using, whether it's Revit or something else, right? You can then you can then use your 3D model to generate your drawings and measurements as well of the site. Okay, then you can use this for your planning, for your conceptual drawings, for your design documentation, and even for your shop drawings as well. Okay, right. The other way to do this scan to BIM process also is where you actually do, you actually have your 3D model ready. Remember I told you about the LOD 400, right? And then moving to 500, which is the as-built verification. You already have your LOD 400 model on the left, okay? And then what you want to do is then you start with the scanning and processing, okay? To generate your model, your virtual reality model. And then after that, send that to the HQ and use that to take your measurements to do as-built verification, okay? Right, so here is the other way of doing it. To have your 3D model. Okay. All right. Let's see, any questions at the moment? No. Okay, good. Let's continue. All right. So the scan to BIM process, as I've shown, right, there's a few different ways to implement this. You can either A, use scanning to do your as-built verification. That's one. Or B, where you actually employ 3D scanning before construction so that you can have an accurate 3D representation of the project site, and then you input your 3D model into it for your design, concept and design. Okay. All right. Yeah. There you go. Where then after we put it back and update the 3D model that you have. So we take the measurements over here and then we update it back into the 3D model. All right, so that's the simple application of it. All right, now I've gone through a few different things here and then come up with a few concepts and things like that, right? So obviously at this moment, everyone hopefully is a bit excited about the idea of implementing virtual reality. And I think this is probably popping to mind right now. Like, okay, what do I do now? I've heard of this, I've heard of that. I need to implement this, do that, and things like that, right? So there is quite a multitude of ways to process this data because it's so flexible, right? And it's able to be used in many, many different ways. So I want to leave you guys with a few suggestions for you guys, for you to consider and explore on your own. There's a lot of materials and resources out there, and I'm sure everyone at FTK as well, you have your own internal resources, and obviously I'm sure your lecturers are obviously a good resource as well. Okay, all your students, make sure you all talk to your lecturers and ask lots and lots of questions. Okay, yeah. So now, what I want to leave you all with is, if you want to explore a little bit further into sort of like creating virtual reality capture and creating your own virtual reality, right? Okay, so what are some of the things that you can look into that I can suggest, right? On the left-hand side here, basically what I would suggest is your mobile apps that's available, your free mobile apps that you can go into, whether it's your Android store or your Play Store, Play Store or iStore, where Adobe and Autodesk actually have free mobile apps that allow you to use photogrammetry to capture small objects. Okay, all you have to do is download the software, and then after that start to take multiple photos from various angles of an object or a space or whatever, and it can generate for you. So you can start playing around with that already. Okay, then as students, you can also sign up for free software from, I'm sure a lot of the software vendors have like an academic version that you can start playing around with. So some of them are like 3ds Max. Okay, wait, why is that sharing? Resume share. Okay, yeah. There is 3ds Max. There is Autodesk Maya. Okay, and then there's also Autodesk Revit as well. So these are just some of the different. Hold on, I've switched again. Sorry. Is that better? Okay, are you guys seeing the main screen again now? Yeah, I think so. I think that works. Are you guys seeing the main screen now? Yes?
Yes, sir.
Yeah, okay, good. All right, hopefully, yeah, hopefully everyone can see the main screen. Yeah, okay. So, let's see. Okay, so 3ds Max, Autodesk Maya, and Revit, these are sort of like what you would call your processing tools, okay, where you can export, where you can import your point cloud data and start to play around with the modeling there, okay. Then after, if you move on towards Rhinoceros, SolidWorks, and even Blackmagic Design, these are the ones where you can start to more easily manipulate the 3D model. So 3ds Max, Maya, Revit, and maybe to a certain extent, the simpler ones such as like Matterport and like a Recap, that one is just for you to start viewing and just do minor tweaks to your model, right? And then, but if you go towards Rhinoceros, SolidWorks, Blackmagic Design, right, you actually have a much richer option of actually playing around. Actually, Maya as well, Autodesk Maya has that option as well, right? And then after you start to play around with this 3D mesh, and everything, you can then push it to Unity or even Unreal Engine, all right, where you are now going to start creating your virtual reality and hosting it on a gaming engine, all right, so that anyone can go in and explore and experience this environment together with you, all right. Now, to sort of like quickly simplify this for you, I can do a simple exercise with you right now. Okay, so if you remember the slides that I showed earlier, which is about the data capture and what is generated, right? So the point, once the raw data comes out, it's actually a point cloud. All right. So if you look at take your hands right now and you just put your 5 fingers out like that as a claw, each of those points of your finger, tips of your fingers, that's a point cloud, right? Okay. So the laser has shot out and then it's generated these point clouds over here. Okay, now you can't use this data yet because it's just the raw data. Now what happens is then you need to send it to something like 3ds Max or Maya where it has to then put a surface onto it. Okay, now then you take this point cloud and then you just take 3 fingers. You just choose 3 fingers. Then you put it to your face over here, right? Okay, so now this point over here on your face there, right? Now the 3 points that touch to your face, okay, so that is considered one surface already, all right? Okay, now you take that white surface there, then you put your hand towards it. So then if you look at it, that is your flat surface already, right? So 3 points, 1 triangle, that is 1 flat surface, right? So that's how you create, so that's how all this software will generate your solid surface for you, right? Now, if you take that same 3 thing there and then put it to your face again, now, is that the same level of detail as the side of your face, the cheekbone, the whatever and stuff like that? No, right? But if we close the 3 points and make it a little bit tighter, will that be more accurate to whatever surface of your face that is? Yes. Then you start times by another triangle, another triangle, another triangle, another triangle, another triangle. That's how you come up with a higher accuracy of your 3D model, right? Okay, yeah. So that's how it does. So that means all the point clouds that's being spread out all across your surface, right? In this example here, your own face, the processing, the software will process it by generating a triangle, and that's how you create that model, that surface there. Okay, all right. So then, please feel free to check out some of this software there, play around with it, and then you know, who knows, maybe this might be one of your year-end projects to showcase the capabilities for FTK as well. Okay, and then once again, we're leaving you with quite a lot of information. So if you do have anything that you want to ask us about, you know, for those who are viewing us on Facebook, because we invited some of our customers on online as well, right? So if any of this is once we implement it onto your actual construction site, please call any of my colleagues there, Mike, Arif, or Ash. They can help you with any of your requirements. Okay. For students, if anything here piques your interest and you just want to say, hey, what resources can I look into? Please feel free to contact any of my colleagues over here as well. Okay. We'll be more than happy to share our knowledge and expertise with you guys. Okay. Because like I said, again, FTK, you guys are creating the future for Malaysia. All right. You will be constructing and really creating our new reality. Okay. So yeah, having said that, I would like to end with yes. So my message to everybody here is start constructing your own reality. Okay. Okay. That's all from me.
Thank you. Thank you very much, Mr. Bruce. Wow, this kind of VR technology, I think the most relevant in nowadays, because due to COVID, we can't go to the site for physical, then to meet someone and to see. And then I think this is the most relevant in this time. And if I'm not mistaken, maybe VR technology can be used to not only in construction, but it can be used, for example, in Legoland and also Sunway Lagoon, so that they can go for virtual, right? Virtual, for example, for the kids and so on. I think it's quite interesting. It will make you relevant at this time.
Yeah, and because I think if I could just quickly add to that, when we are talking about like construction technology, right? That is basically our built environment. You know, what we interact with, our roads, our buildings, and things like that, right? And it'll be more than it's very important to have a virtual representation of that, so that as more and more screens get thrown in front of our face, right? We need to be able to have quick access to that virtual. What is called a digital twin, you know, yeah, whether it's used for fire and safety emergencies, you know, or for any other applications like your smart driving, automation and things like that.
Yeah. And also I think the VR technology can be used for the skyscrapers to know the highest level, whether the structure is cracked or so on, so they can get the very accurate picture.
Yes,
for example, right?
Correct. I think for skyscrapers, I think one good example here is our own national utilities, right? Like for instance, TNB and also telecom as well. For dangerous areas, or maybe like all those high communication towers, or even all the power lines and things like that, they actually use drones to do
sure.
Things like that first, you know. So yeah, it's
due to the safety reason, right?
Yes, correct. Yeah, the safety survey, and then for them to plan what they need to do. Yeah, and this leads quite well into there's a question here by Tan Xiaming on do you need a apply for training to handle a drone? Actually, yes, you do. Why do I say that? Not because, do you need, is the drone so complicated that you need special training? No, actually the training is specific to what is your application. So like for instance, if you are going to be doing this site survey for oil and gas, for all these utilities, high danger areas, you need specific training, safety training, to make sure that your drone is at a safe distance, how you set up, what drones you can and cannot use, things like that. If you're going to be going towards maybe construction for survey and things like that, right, you need to understand how to set up your flight path and plan how you want to actually fly your drone across a construction site, because how you plan your flight path will also determine the level of speed and accuracy that you can manage. All right, and then obviously if you're going towards like your wedding photography, movie photography, and things like that, you need a bit of training to understand how, because you're moving in, I can't remember what they say again, 4D, 5D reality, where you have to go and move the camera, move the drone, and also go and get everything working at the same time as well. Yeah. Okay.
Okay, let me see the question in the Facebook. I think there is no question. And then all the questions given in the chat room, so you have already answered.
I hope I've covered everybody.
One last question from me.
Yes.
Okay, Mr. Bruce. VR technology, can we estimate the bedrock level inside the soil?
Oh, okay. So bedrock level, that would be something that would need specialized equipment. Actually, that means you need ground penetrating radar to use. Photogrammetry that would be different technology, because that one still relies on images and everything to generate a surface. But once you go past the surface, then we're talking about specific equipment like ground penetrating. Yeah.
Okay.
Yeah.
I think
for all you students that might be going into civil, and also one thing is there's a lot of challenges where you are talking about trying to find underground utilities. Okay, so especially when you're going to brownfield construction where there's some existing infrastructure lying around there, it's always a challenge to try and identify where these existing underground utilities are and stuff like that. So obviously when you dig into it, for your foundation or whatever, right, you don't want to cut fiber optic line or whatever and things like that. Yeah. So that is quite a challenge, and we do receive quite a number of requests for this, inquiries about what kind of technology they can use to easily identify training systems. Yeah.
Okay, we reached at the end of the session, Mr. Bruce. Just want to recap and just want to conclude that you have a good and very interesting topic for this evening, Mr. Bruce. Yeah.
Thank you.
So that I give back, I would like to express my sincere appreciation again to Mr. Bruce and also Mr. Jerry for their valuable knowledge sharing to us. And I give back to the floor to the pretty MC, Wan Emira. Okay, thank you.
All right,
thank you, Mr. Bruce, and thank you to those who raised up your questions, and hope you are satisfied with the explanation given by our honorable speakers. We are approaching to the end of our talk for today. We would like to thank to all participants for your time and commitment throughout this talk. And not to be forgotten to both of the speakers, million thanks for spending your precious time with us. We hope this valuable relationship will never end, as we can keep on the knowledge transfer program from time to time. And also, we would like to thank to all team members in Department of Civil Engineering Technology, JTKA, Faculty of Engineering Technology, FTK, University Tun Hussein on Malaysia for undivided support. Also, don't forget to fill up the attendance link given in the chat box, as you will be given the e-certificate later on. Thank you to all. We end our session. Have a good day.
Please, audience, thanks. Say thanks to Mr. Bruce.
Can I have a special request?
Oh, okay. Special request.
Can we take a picture once more? Because last time when we take the picture first in the early session, we don't have the full picture of everyone with video. So if everyone can turn on the video and giving your best smile. Ya, macam tu. Wah, nice. Oke, kita tunggu yang lain. Okay, still waiting for the other to turn on the video. Dr. Ashraf pun tengah memandu. Alright, I'm taking the picture in 1, 2, 3. Alright, next one. And the last page. Alright, thank you everyone.
Thank you.
Thank you.
Thank you for the great presentation.
Thank you so much.
Thank
you.
you.
Bye.
Bye. KJ, thank you.
Thank you.